All right, tidiers and organizers, here's your last part of level 2, the last new piece, which is really just taking what we've learned and putting it all together. So we're going to practice determining equivalent expressions. So we need to determine if each set of expressions are equivalent. So we're going to decide if they're equivalent or not. For each set of expressions that are not equivalent, we're going to rewrite one of the two expressions to make it equivalent with the other one. So we're basically going to fix it if it's not equivalent. If it is equivalent, we're just going to show that with our work and circle equivalent. Now you might be wondering, like, didn't we already kind of prove this last time? Well, we did, but we were using substitution. But now this time we're going to use our properties and combining like terms and that knowledge to show whether it's equivalent or not. Not that we couldn't use substitution too, but really that takes a little bit longer in my opinion. So let's look at this first one. Again, I'm noticing this number next to the parentheses like that, so I'm going to assume let's try distributive property first to see if they're equivalent. Because it's really hard to tell if they're equivalent just by looking. Now sometimes you can, but you're really in your head using the properties anyway, so you might as well write it out just to make sure you don't make a mistake. So when I do 5 times x, I get 5x, and then 5 times 1 to get 5, and then I add the addition sign in there, and so I get 5x plus 5. Okay, and so when I look at that, I get 5 plus 5x over here, and that really is the same thing because of the distributive property and commutative property. We talked about that way back when in level 1 briefly, and so these are equivalent to one another. So we do not, where'd my circle go? There it is. So these, we do not need to rewrite anything because these are equivalent to each other with the distributive property and commutative property. Go ahead and write those. I know it didn't ask you to explain, but it is good to understand why it is that these are equivalent. Okay, so make sure you do that. All right, let's look at just 2 more. Real simple, same exact thing. And again, I notice a number next to the parentheses like that, so I'm going to try distributive again and see if I get the same thing as I do on this side of 3a minus 2b. So I'm going to do 3 times a to get 3a minus 3 times 2b to get 6b. So when I look at that, that is not the same, so these are not equivalent. Okay, because I got 3a minus 6b versus 3a minus 2b. Now, to rewrite this is why I suggest that you go ahead and do the work anyways, because really this is our equivalent expression, because remember how it said to rewrite when if one of them is not equivalent to the other, so you can make it equivalent. So this would be, let me get my things back up, hold on one second, where'd they go? There it is, I moved it. Okay, so again, not equivalent. There we go. So when I actually did the expression over here, when I actually did the distributive property, I got 3a minus 6b, and so that would make this equivalent to the left side, right? Like if these two are equivalent to each other. So if I change the 3a minus 2b to 3a minus 6b, now they would be equivalent. And so that's what it's asking. That's why doing the problem anyways just kind of makes it some of the work's done for you already. Now I could also change this side, but this side would be a little bit more complicated to change because I would need to rearrange some more numbers than just what's there. So this is what I would suggest as changing it. Again, not that you couldn't completely change this side, but it's a little bit easier if you just changed the way I showed you, okay? All right, there's one more here. So I've got 3x plus y to the third equals y plus y plus y plus x times x times x. So this one I'm going to use combining like terms. And I'm going to use that on the right side because there's really nothing else to combine on the left side. So I'm going to see if this right side turns out the way the left expression is. So if I do y plus y plus y, I see that there's 3 of them, so that's going to be 3y because I'm adding them. So adding over and over is multiplication, so 3 times y, versus x times x times x is going to be x to the third. So I get 3y plus x to the third. That is not the same as what I got over here, so these are not equivalent to each other, and this would be my way to fix that. I can say 3y plus x to the third, or x cubed. This changing this side, the left side, to this makes it equivalent to the right. Now, I also could change the right side to look like the left side. I could do x plus x plus y times y times y. Like I could just flip-flop the variables, and then that would be 3x plus y to the third. So you choose what you would like to change, but since they're not equivalent, we did need to change one. Okay, so now you have a little bit of practice to do. Make sure you get a teacher's signature on that before moving on to your level 2 assessment, and then you're almost there. Good luck.